Today we will be solving a linear programming problem using the simplex method. This is our original problem. Please note that it is a maximization problem. We're going to be using the simplex method. We're going to be using two different forms of it, the matrix form and the tableau form. So there's going to be a lot of similarities through each iteration. And with both forms, we want to do the same thing in each iteration. We want to identify the current basic variables and their current value, identify the current objective function value, test to see if the current solution is optimal. If it's not optimal, we're going to select an entering and leaving variable, and we're also going to test for unboundedness. For the initial iteration, we're going to have to select the basic variables. It's a good idea to choose the slack variables as the basic variables, because then we're guaranteed to have an initial basic feasible solution, which is right there at 0, 0 in the graph. For step 1 of matrix form, we want to solve for the values of each basic variable by multiplying b inverse by little b. Here's what we get. x3 equals 5, x4 equals 3, and x5 equals 2. We get the same values for tableau form by simply looking at the tableau. The independent rows are the basic variables, which are right here, and the values on the right-hand side in that row that has the 1 in it is the value of the basic variable. So x3 or slack 1 equals 5, slack 2 equals 3, slack 3 equals 2, just like in matrix form. Next, we're going to check for optimality. For each non-basic variable, we want to see the cost improvement for if we brought it into the basis. This is done by multiplying CB by B inverse by each A of the non-basic variable and subtracting that value by the cost associated with that variable. For a maximization problem, if at least one of these values is negative, then we are not optimal. At this point, it is also easy to select the entering variable, which for a maximization problem is the lowest negative number. In this case, it is x2. Right here, it's -3. Notice these values are the same as the values in row 0 of the tableaus for the non-basic variables. Test for optimality in the tableau form, that's all we need to look at is row 0. If at least one value of a decision variable is negative, then we know we're not optimal. And again, we want to choose the lowest negative number in 0. So in this case, it is x2, right here. Next, we need to check for unboundedness and choose a leaving variable. In matrix form, we multiply b inverse by a of the entering variable. And when we do that, we get this vector right here. And as long as one of the values in this vector is greater than 0, we are not unbounded. In this case, we have 2. Next, we need to choose the leaving or blocking variable. In order to do this, we need to multiply b inverse by little b, and we get this vector, and we need to divide each number in the vector by its associated value in the a of the leaving variable, which is a2. So once we do this, we get 5 over 1, 3 over 1, and 2 over -2. We select the lowest value that is non-negative. Doing that, we get 3, which is associated with the second slack variable, and that's the leaving variable. So in tableau form, we test for unboundedness at the same time that we perform the minimum ratio test to select the entering variable. If the ratio test yields all negative numbers, or an infinite number for either the matrix or the tableau form, then we know that our problem is unbounded. So when we perform the ratio test in tableau form, these are the values we get. They're the same values as the matrix form. S2 is the lowest positive number, so we know that S2 is going to leave the basis, just like we found out in the matrix form. Now at this point, the next step is to update the matrices and the tableau. For the matrices, at any point where there was an entering variable or entering variable values, we switch that with the leaving variable or the leaving variable values. Doing that gives us these new matrices. In tableau form, where the entering variables column crosses with the row of the leaving variables column, which was previously right here, we perform pivot operations at that point And that's how we get our new tableau. At this point, we can take notice of some similarities. B matrix will always be equal to this 3x3 matrix right here in tableau form. CB will always be equal to this 1x3 area of the tableau. XN, or N, will always be equal to this area of the tableau, and Cn will always be equal to this area. So now we've moved on to our next iteration, and we're going to do the same things that we did last time. We're going to identify our basic variables, which as we can see are the same. x2 equals 3 right here, because x2 is in the middle. S1 or x3, that is the same, equals 2. x5 or slack 3 equals 8. Next we need to check for optimality. So after we use this equation again for our two a's that are non-basic, we get a -8 and a -3. So we have one negative number, so we know we're not optimal. And it's our only negative number, so we know at that point we're going to choose that one to enter the variable. Or to enter the basis, which is x1. In tableau form, all we got to do is look at the first row, or row 0 again. We have a negative number, we only have 1, so we're going to choose that as our entering variable, and we know it's not optimal. Next, we're going to test for unboundedness in the matrix form using this equation right here. And x1 is entering, so it's b inverse times a sub 1. And this is the vector we get, and we have a 5 right there, so we have at least one that's greater than 0. So at this point, we're not unbounded. And then we're going to choose the leaving variable by using this equation again and selecting the lowest positive number. In this case, there's only one positive number because we have 2, -3/2, and -8/3. So we cross those two out and we get 2, which is our minimum. So we know that x1 will be entering the basis and our first slack variable will be leaving it. So going back to tableau form, again, the minimum ratio test, since x1 is entering, we divide the ratio, the right-hand side values by the values in the x1 column, and this is the ratio test values we get. Again, S1 is the only one that's positive, so we know that S1 will leave the basis. And then matrix form, we swap out our leaving and entering variables, and these are our new matrices. Tableau form, we perform our pivots right here, and this is our new tableau. And again, we do the same thing. We identify our new basic variables. We have x1 equals 2, x2 equals 7, and our third slack variable equals 14. We can see that in both places because here's our new tableau right here. We're going to check for optimality again by using these equations, and for j equals 4, which is our second slack variable, we get a -5. And we have a -5 right here in the tableau as well. So we know that we're not optimal and that S2 needs to enter the basis, which is also x4. So next, for the matrix, we need to test if we're unbounded by doing b inverse times a sub 4, which is our entering variable. When we do that, we get a vector of all -1s, which are all less than 0. So at this point, we know that our problem is actually unbounded, and we're not going to be able to have an optimal solution. And we could actually see this graphically at the beginning, but we wanted to solve this to make sure. Now we can't, in order to check for if we're unbounded in tableau form, we have to perform the minimum ratio test to do that. So when we perform the minimum ratio test with S1 entering, we have -2 or 2 over -1, 7 over -1, and 14 over -1, which yields 3 negative values. This is the point in tableau form where we know we're unbounded. I hope this was very beneficial, and if you have any further questions, feel free to email me at wwl0002@auburn.edu.